Okay students, so now today we start chapter number 9 of 11, mechanical properties of solids. Okay, easy chapter students, mechanical properties of solids. So we discuss rigid body. Students, what is the meaning by rigid body? So see, in the rigid body, distance between particles remain invariant, then it is known as rigid body. Means during the motion shape of rigid body is not changed, then it is known as rigid body. Okay, suppose when we open the door and close the door, then shape of the door is not changed. Why? Because door is a rigid body. Now we discuss deforming force. So what is the meaning by deforming force? Okay, when force is applied and dimensions of body, dimension of object are changed, then the force is known as deforming force. Suppose if length is changed, radius is changed, volume is changed, shape is changed, then the force is known as deforming force. Okay, so what is the meaning by deforming force? When force is applied and dimensions of body are changed, dimension of body are changed, then it is known as when force is applied and dimension of body are changed, then it is known as deforming force. Okay, then it is known as deforming force. Okay, when force is applied and dimension of body are changed, then it is known as deforming force. And so now we discuss elastic body or elasticity. So what is the meaning by elastic body? Elastic body means what? When when deforming force is removed and if body can get its original shape, okay, then it known as elastic body. Suppose when we compress the spring and the release, then spring gets its original shape. Okay, so what is the meaning by deforming force? What is the meaning by elastic body? When deforming force is removed and body can get its original shape, then it is known as what? Elastic body. Okay, now what is the meaning by inelastic body? What is the meaning by plastic body? When deforming force is removed and body cannot get its original shape, then it is known as plastic body or inelastic body. Suppose polythene, when we stretch the polythene, then it is deforming force. Okay, when we stretch the polythene and now deforming force is removed, then polythene cannot get its original shape, so it is known as plastic body. But students, in a practical life, every body is a partially elastic body, means body can get partial its original shape. Okay, થોડુંક તો ડિફોર્મેશન આવી જાય. સો In a practical, every body is a partially elastic body, but we can form elastic body vulcanized rubber. Okay, in case of vulcanized rubber, it is most probable chance it can get its original shape. Okay, so this is the meaning by deforming force, elastic body, inelastic body, partially elastic body. Chalo, so now we discuss strain. Okay, there are the three types of strain, students. So now we discuss strain. So what is the meaning by strain, students? Strain means what? Change in dimension by original dimension. Okay, when deforming force is applied, as we know, dimensions are changed. Okay, so what is the meaning by strain? Strain is a ratio of change in dimension so what is the meaning by strain? Strain is a ratio of change in dimension by original dimension. Okay, what is the meaning by strain? Strain is change in ratio of change in dimension by what? By original dimension. Chalo, now students, there are three types of strain: longitudinal strain, volume strain, and shearing strain. Okay, chalo, so first we discuss what? Longitudinal strain. Generally, what is the symbol of strain? Epsilon, and longitudinal strain means epsilon L. Longitudinal strain means what? Epsilon L. So what is the meaning by longitudinal strain? Longitudinal strain means change in length. Okay, in case of longitudinal strain, we consider change in length. So change in length by original length is known as longitudinal strain, delta L by N. Okay, change in length by original length is known as what? Longitudinal strain, delta L by N. But see students, there is no unit of strain because meter cancel. Now see here which type of force is applied. Suppose this is the cylindrical wire. What is its original length? L. Now students, if we want to increase the length, then we applied perpendicular force. Okay, so here we apply perpendicular force. Okay, here we apply which type of force? Perpendicular force. So it is the deforming force, right? Chalo, so now its new length becomes what? Now its new length is what? L plus delta L. So what is the change in length? Final minus initial after applying the force. What is its new length? L plus delta L. So what is the change in length? New length. What is new length? L plus delta L. What is old length? L. So what is the change in length? Delta L. So what is the longitudinal strain? Change in length by original length means delta L by L. Chalo, now next student, next we discuss what now. Longitudinal strain have two types. Okay, two types of longitudinal strain, tensile strain and compressive strain. Chalo, two types of longitudinal strain. First one is what? Two types of longitudinal strain, students. First is tensile strain. First is tensile strain. What is the meaning by tensile strain? If deforming force is applied and length is increased, then it is known as tensile strain. Okay, so in the case of tensile strain, length is increased. So in case of tensile strain, length is increased. Now second strain is compressive strain. Okay, now second strain is what? Compressive strain. Now compressive strain means what? Suppose if this is the wire, if force is applied in that direction, then length is decreased. If force applied in that direction, then length is decreased. So then it is known as compressive strain. Okay, so longitudinal strain have two types. Tensile strain, formula same, delta L by L, but in a tensile strain, length is increased. In compressive strain, length is decreased. Okay, so what is the meaning by longitudinal strain? Change in length by original length, delta L by L, and there is no unit of strain. Okay, it is a dimensionless, because change in length, then it is meter by meter, so it is cancelled. Chalo, now second strain, second is a volume strain. So now volume strain, students. So volume strain means what? Volume strain means change in volume by original volume. Okay, and its symbol is epsilon V. Means what? Change in volume Okay, what is the meaning by volume strain? Change in volume by original volume. Okay, what is the meaning by volume strain? Change in volume by original volume, delta V by V. Delta V by V means what? Change in volume by original volume. Now students, in which case volume of body is changed? When force is applied to each and every point of body, then volume of body is changed. Okay, suppose if this is the body, okay, if volume is applied to each and every part of the body, then volume of body is changed. In first case, we apply perpendicular force. Here if suppose if you want to change the volume of this body, then force is applied to each and every part of body. So volume of body is changed when force, deforming force, when force is applied to each and every point of body, when force is applied to each and every point of body. Okay, volume of body is changed when force is applied to each and every part of the body. Volume of body is changed when force is applied to each and every point of the body. In that case, volume of body is changed. Okay, so now see students, this is we consider delta V by V means what? Change in volume by original volume. Now volume of body is changed when force is applied to each and every point of a body. સપોઝ સ્ટુડન્ટ્સ અમે તમને આની પહેલાં એક્ઝામ્પલ આપ્યું હતું, ઇફ યુ વોન્ટ ટુ ઇન્ક્રીઝ ધ વોલ્યુમ ઓફ બોડી, તો તમે શું કરશો? એની અંદર એર જવા દેશો. ઓકે, તો ડ્યુ ટુ that air is applied force to each and every part of the body, to each and every part of the balloon, then volume of balloon is increased. હે ને, તમે ક્યાંય બલૂન બ્લો કરાવેલો હશે તો શું થાય? that air moving into the balloon, and by the air force is applied to each and every point of the balloon and volume of balloon is increased. So students, this is possible in a what? Fluid. Okay, in fluid force is applied, air is a fluid, so in a fluid force is applied to each and every part of the body. So this is the volume strength, but remaining one remember one thing, volume of body is changed when force is applied to each and every point of the body. So this is the volume strength. Now we discuss shearing strength. Now students, in the case of shearing strength, okay, in case of shearing strength, in case of shearing strength, tangential force is applied. In case of longitudinal strength, perpendicular force. In case of volume strength, force is applied to each and every part of the body. In case of shearing strength, tangential force is applied. So due to tangential force, due to tangential force, shape of body is changed. Okay, due to tangential force, shape of body is changed. In first case length change, in second case volume change, and here shape change. Suppose this is the pen, if suppose this end is fixed and now we apply the force in that direction, in the tangential direction, then its shape is change, incline થઈ જશે. Okay, so in tangential force shape of body is changed. Now see, we want to obtain formula of shearing strength. So how to obtain the formula of shearing strength? See, chalo, suppose what is the height of the cylinder H? What is the height of the cylinder H? Now we applied here tangential force. Okay, now we apply one tangential force. So due to that tangential force, its shape is changed. Now it's shaped like that. Okay, so what is its original shape? This is its original shape. Okay, this is its original. So what is the now change in, what is the displacement? See here, delta x. Suppose this is the theta, this is the height. Okay, when we apply the tangential force, its shape is changed. When we apply the tangential force, its shape is changed. So see, what is the displacement? See here, delta x. Okay, chalo. Because we apply the tangential force, as we given the example, suppose this is a pen. If suppose this end is fixed here and we apply the force in that direction, tangential, that it is bent. Okay, so its shape is changed. So same here, shape is changed. So if we take tan theta, then delta x by h, that delta x by h is known as shearing strength. Okay, so shearing strength means what? Delta x by h. Delta x is the displacement and h is the height, original height. So what is the formula for shearing strength? Delta x by h. Okay, chalo. So again there is a no unit because meter cancel. So we discussed the three types of strain. Longitudinal strain, in case of longitudinal strain, perpendicular force is applied, so length is changed, so its formula delta L by L. In volume strain, force is applied to each and every part of the body so its volume change. And what is the formula for volume strain? Delta V by V. And in that case tangential force is applied, so shape of the body is changed, so it is known as shearing strain, and delta x by h. Okay, what is the formula for shearing strain? Delta x by h. Sure. Now students, we discuss stress. It is very important topic, stress. So now we discuss what, students? Stress. So stress means what? Stress means restoring force. See, suppose any plastic body can get its original shape. Any plastic body, any elastic body can get its original shape due to the what? Due to the what? Restoring force. Suppose when we compress the spring, okay, then restoring force is act in opposite direction, and due to that spring can get its original shape. So that due to that restoring force, any elastic body can get its original shape. Okay, so due to restoring force, elastic body can get due to restoring force, elastic body can get its original shape. Okay, due to what? Restoring force, elastic body can get its original shape. Due to which force? Due to restoring force, elastic body can get its original shape. So students, now see the next concept. What is the meaning by stress? Stress means stress is restoring force per unit area. Okay, what is the meaning by stress? Stress is restoring force per unit area. Okay, so what is the meaning by stress? Stress is restoring force per unit area. Chalo, so what is the meaning by stress? Stress means force by area. Okay, what is the meaning by stress? Force per unit area. Restoring force so stress, what is the symbol of stress? Sigma. And what is the unit of force? Stress is what? Sigma, and stress means restoring force per unit area, F by A. Chalo, so it means students, when we increase the strain, suppose when we increase the strain, when we apply the deforming force, then restoring force is also increased. Okay, so when deforming force is removed, substance can get its original shape, but stress is increased up to certain limit. After that, okay, suppose this is the elastic wire. Okay, now we increase the length of wire. Now when we removing this force, for substance can get its original shape. It means when deforming force is increased, when strain is increased, restoring force is also increased. So when we remove the force, substance can get its original shape. But after certain limit, when strain is increased, stress is not increased. Okay, it means when we apply the deforming force after certain limit, substance cannot get its original shape. That is known as elastic limit. Okay, chalo. restoring force is increased up to certain limit. After that, body cannot get its original shape. Okay, after that body cannot get its original shape. So this is known as what? Elastic limit. So this is known as what? Elastic limit. So now what is the unit of stress, students? Unit of stress is what? Newton meter square or Pascal. Okay, force by A. So Newton per meter square or Pascal. And what is the dimensional formula for Newton? M1 L1 T minus 2 by L2. So M1 L minus 1 T minus 2. M1 L minus 1 T minus 2. So what is the unit of stress? Newton per meter square or Pascal. Chalo, so we discuss what? Elastic limit. Done, students. So these are the basic stress and elastic limit. Chalo, now students, as we know, three types of stress. So three types of stress also. Okay, we discussed three types of strain. So here three types of stress also: longitudinal stress, shearing stress, and volume stress. Now we understood one example, students. See. Suppose this is one cylindrical wire and force is applied in that direction at an angle what? Theta. Okay, at an angle theta. Chalo, so we consider it two component, students. We consider two components where the angle is formed. We consider cos theta. So here we consider cos theta and here we consider sin theta. So students, see from the figure, f cos theta is perpendicular and f sin theta is tangential. Okay, see, suppose this is the cylindrical rod, so f sin theta is in that direction, so f sin theta is tangential and f cos theta is perpendicular force. So f cos theta is known as longitudinal force, or we can say that length, due to that force length is increased, so we can say that it is tensile force also. And f sin theta is tangential force. So or it is known as shearing force, because due to that shape is changed. Okay. So what is the meaning by longitudinal stress? What is the meaning by longitudinal stress? Longitudinal. What is the meaning by longitudinal stress? So longitudinal stress means what? Longitudinal force by area, because stress means force by area, but here we consider tensile force or longitudinal force. Why it is F cos theta is known as tensile force or longitudinal force? Because it is perpendicular to the cross section of wire, and due to that force length is increased. Due to F cos theta length is increased, so that's why it is known as tensile force. So here we consider force by area, but which force? Longitudinal force. So we consider F cos theta, F cos theta by area. Okay. Now what is shearing stress? Now what is the meaning by shearing stress? In the case of shearing stress, force is tangential. As we know, tangential force is applied. So what is the tangential force? F sin theta by area. So students, as we know, stress, what is the general formula of stress? F by A. That is same for all the type of strain, longitudinal, volume and shearing. Strain માં બધા માટે અલગ અલગ ફોર્મ્યુલા થી જોવો કે longitudinal strain means delta L by L, volume strain means delta V by V, shearing strain means delta X by H. But in the case of all the type of stress, formula is same, F by A. But what is the different thing? In case of longitudinal stress, we consider perpendicular force, F cos theta. In case of shearing stress, we consider tangential force. Okay. Chalo, now what about volume strain? Now what about volume stress? Now what about volume volume stress, student? See, so volume stress is what? Force by area. But see, in that example, student, volume of body is changed when force is applied to each and every point of a body. Okay, so students, see, this is the body, then here force is applied to force is applied to each and every part of the body, students. So that's why that volume stress, force by area, this volume, this is possible in a what? This is possible in a fluid. Okay, as we know, given the example air, when air is moving inside the balloon, then force is applied to each and every part of the balloon by the air, and volume of balloon is increased. So students, this is possible in a fluid, so that's why force by area for volume stress. In case of volume stress, force is applied to each and every part of the body, and this is possible in a fluid. So that's why volume stress F by A is known as pressure. When a student volume stress is also known as hydraulic stress. So volume stress is also known as pressure. Okay. So students, this is the basic concept. Okay, volume stress. So stress has a unique formula F by A. So now students, we want to discuss Hooke's law. So now what is Hooke's law? So according to Hooke's law, stress and strain are proportionals to each other. It means what? When strain is increased, restoring force is also restoring force. When strain is increased, restoring force per unit area is also increased, and after the removing deforming force, person can get its original set. Okay, suppose when we compress the spring, then restoring force in a spring is also increased. So when deforming force is removed, spring can get its original set. Okay, suppose plastic students. So when we in the case of plastic, when deforming force is increased, there is no restoring force in the plastic. So after the removing deforming force, plastic cannot get its original shape. Okay, agar restoring force build up thai, then and then substance can get its original shape. Chalo, so according to Hooke's law, stress and strain are proportionals to each other, but up to 1% limit. Up to 1%. આપણે ગ્રાફ અહીં જોશું આનું. ચલો, so stress and strain are proportionals to each other. So stress means sigma, strain means epsilon. Replacing proportional, we place K. Either you can place E, elastic module. So K means what? Stress by strain, and K is known as elastic modules. So what is the meaning by elastic modules? K, and what is the, it is also known as E, capital E. So K means elastic modules, it means stress by strain. Ratio of stress by strain is known as elastic modules. Now students, there are the three types of elastic modules: Young modulus, Wulff modulus, and shear modulus. Chalo, so now we discuss three types of elastic modules. First Young modulus, then Chalo, so now we discuss first type of modules, that is young modulus. It is the one type of elastic modules. So what is the meaning by young modulus? Young modulus, why mean? આપણે પહેલા આપણે ડિસ્કસ કર્યું છે સ્ટુડન્ટ્સ. young modulus means what? Longitudinal stress, it is the ratio of longitudinal stress by longitudinal strain. Okay, it is the ratio. Young modulus means what? It is the ratio of longitudinal stress by longitudinal strain. Okay, young modulus means what? It is the ratio of longitudinal stress by longitudinal strain. Chalo, so what is the formula for young modulus? What is the meaning by longitudinal stress? F by A. What is the meaning by longitudinal strain? Delta L by L. Okay, what is the meaning by longitudinal stress? F by A. What is the meaning by longitudinal strain? Delta L by L. So we can also write FL upon A delta L. So we can also write FL upon A delta L. Okay, FL upon A delta L. F by A is a stress, longitudinal strain, delta L by L is a longitudinal strain. So what is the formula? FL by A delta L. Y is a young modulus, A is a cross section area. And what is the unit of young modulus? What is the unit of young modulus? See, stress by strain. So what is the unit of stress? F by A, है ना? But strain have a no unit. So what is the unit of F by A? What is the unit of stress? Newton per meter square or Pascal. So what is the unit of young modulus? F by A or delta L by L. Chalo, students, now we discuss one question regarding to that. That question asked in 2014. Chalo, copper wire of a fixed volume V. What is the copper wire of fixed volume V? What is the volume? Fixed. Volume is constant, is drawn into a wire of length L. Chalo. When this wire is subjected to a constant force F, the extension produced in the wire is delta L. When this wire is subjected to constant force F, then change in length of wire is delta L. Chalo, copper wire of fixed volume V, volume is fixed, V is drawn into wire of length L. What is the length of wire? L. Now wire is wire is subjected to force L, and what is the increase in length of the wire is delta L. Chalo, now then which of the following graph is straight line? Graph of delta L, graph of delta L versus L, delta L versus L. It means we want to find the relation, students. Okay, we want to find the relation between change in length and original length. Simple. So a copper wire of fixed volume V is drawn into a wire of length L. So volume fixed. So see students, here length is increased, so we use Young modulus. So what is the formula? F by A delta L by L. So FL upon A delta L. Now take delta L as a subject, so FL upon YA. Chalo. Now students, we want to find the relation between delta L and N. So I think they would like that delta L is proportional to L. So eno graph straight line, but not, this is not true, students. See, force is constant. It is given in the question when this wire is subjected to a constant force F. So force is constant, Young modulus is also constant. But what about length and area, students? So when we increase the wire, students, when force is applied and wire is increased, length is increased, then its cross section area is also changed, student. Okay, its cross section area is also changed. Area is changed, students. So see, small cross section area becomes small now. Okay, so area of the wire is changed, students. Okay, so area is not constant, but what is the constant? That volume. See here, constant volume. Volume is constant, students. So see, what is the meaning by volume? Area into length. So if we set here volume, then આપણે volume લાવવું પડશે. Length નો relation તો જોઈએ જ છે. We want to obtain the relation between change in length and original length. But શું set કરવું છે denominator માં? Volume. So volume means area into length. Area તો છે અહીંયા, so divide and multiply by length. So what is the answer? FL square Y by volume. Now force constant, Young modulus constant, V means volume constant. So delta L is proportional to L square. So if they are directly proportional, which quantity are directly proportional? Delta L and L square. So if we draw the graph of delta L and L square, then it is a straight line. Why? Because delta L and L and L square are directly proportional. So if we draw the graph of delta L and L square, then that graph is directly proportional. Okay students, so graph of delta L and L square is directly proportional. Delta L and L square are directly proportional. So option B is right. So and that graph is what? Straight line.